Okay. Share screen still not working. Okay, got it. Okay, let me see if it's working. Can you see the screen?
Visible na po yung presentation.
Visible na. Okay.
Yes.
Yeah, let me see. Can I request the organizers to just let me know if anybody's raising his hand? Um, please just feel free to interrupt me anytime if you have any questions. This is a rather informal talk, so if you have any questions, you can just interrupt me anytime or you can raise your hand, but I will have to request the organizers to let me know if there's somebody who's raising his hand.
We'll
Okay?
let you know. We'll
Okay.
let you know po. Thank you.
Sige, sige. Wait lang ha. Okay. Mm-hmm. Wait lang. It's working. Okay, so as I mentioned, I think this invitation to me, to us, to our group, was prompted by the several news reports that were featured lately, all stemming from the results of the work that we did within the Manila Trench, where we reported the possible presence of gas hydrates. So please, you have to take note that reporting the presence of gas hydrates is different from reporting that we are developing or producing gas hydrates. So we're still a long way away from the commercial production of gas hydrates. We're still at the very, very front end of the whole process because this is the first time that we're doing an in-depth study of gas hydrates. So these are just the contents of this afternoon's talk. Just introduce to you what gas hydrates are, and then give you some idea where the gas hydrates are formed, where do we typically look for them, and what are the tools that are available for us to look for gas hydrates. Okay, so next. So as you can see here in this photo, what you see look like dry ice. So this is how gas hydrates are typically described. They are ice-like crystalline compounds, and they are made up of hydrocarbons, which are typically in the form of methane. So this green circles that you see in the drawing on the left are the gas molecules, specifically in the form of methane, and they are typically embedded or encaged in solid lattices of water molecules. So these white or gray things that you see here are the water cages, where the methane molecules are encased. So these are some photos that are available to show us what the gas hydrates look like. And there's a lot of interest in gas hydrates because of its potential as an alternative energy source. So way back in the early 2000s, even while I was doing my PhD in the University of Tokyo in Japan, a lot of the other countries have already been doing exploration and doing studies pertaining to gas hydrates. So this figure here shows where where the areas that have been identified where gas hydrates are known or are likely to occur. So these are the areas that are shown in the light blue color. And as I said, there's been a lot of interest in gas hydrates recently because of the potential for large volumes of carbon to be extracted from gas hydrates. So when this were earlier reported, when gas hydrates were earlier reported, they were claiming that this is more than twice or three times the volume of the total hydrocarbon resources that can be used by man. So you can see in this graph here, some of the more recent estimates indicate up to 3,000 billion tons of carbon that can be extracted from gas hydrates. And you can see how the natural gas sources or reserves compare, the oil reserves and the coal reserves compare with the volume of carbon that can be extracted from gas hydrates. So you can see here for natural gas, it's up to 96 billion tons of carbon. For oil, it's 160 billion tons of carbon, fossil fuel reserves, and for coal, it's 675 billion tons of carbon. So there are significant volumes that can be extracted from gas hydrates. This is the interest because we are now at that stage where it's not only the Philippines that is very concerned with the depleting fossil fuel reserves that we have from oil and gas resources and natural gas and coal. So the traditional fossil fuels are starting to be depleted, not just in the Philippines, but worldwide. In the Philippines, we're being told that the Malampaya deposit is only going to be good up to 2024 or 2025, but they have extended it up to 2027. And that's just a few years away from near depletion or almost total depletion of our deposits or our hydrocarbon resources. So people are very interested in what gas hydrates have to offer. So is this now the solution to mankind's problems when it comes to energy resources? So this is something that I would like to introduce to you and inform you what is the status of the work that has been done when it comes to gas hydrate exploration in the Philippines. Okay. So as mentioned, gas hydrates, if they are extracted properly, they can produce each cubic meter of gas hydrate is capable of releasing 164 cubic meters of natural gas. So you can just imagine the volume of natural gas that you can extract from just 1 cubic meter. So this is really what is driving all the interest in gas hydrate exploration. So with just a small amount, you are able to extract a significant amount of natural gas that can be used as energy resource. It's typically stable in ocean floor sediments at shallow depths, particularly in permafrost regions, but they typically also occur at depths greater than 300 meters. So I'm putting emphasis on the depth at which it is found because later on we will see what sort of challenges this presents to us when it comes to exploring for gas hydrate deposits. And once they are found, what are the technologies that are available to us if we are going to try to extract these deposits from depths of greater than 300 meters. But as mentioned, there have been variations in estimates of the amount of methane that can be extracted from gas hydrates. So it's from around 3,000 trillion cubic meters of methane to up to 30,000 trillion cubic meters of methane. But that is just based on what current studies are revealing so far. Because if you do further studies, then and if you report that there are indications of gas hydrates somewhere else, then this estimate might subsequently go higher. Okay, so why all this interest in gas hydrates aside from putting a lot of emphasis on this being a major alternative energy resource? uh, a lot of those doing studies on gas hydrates are also suggesting that this is a greener and cleaner version compared to the traditional fossil fuels that we are using now. So this is oil, gas, and coal resources. And given the volume of methane that can be extracted from gas hydrates, studies have also indicated that this can be a potential energy source. Some conservative estimates put it at 10 to 25 years na energy source, but there are some that are really aggressively pushing that it can be a potential energy source for the next 200 years if we base it on the current level of energy consumption. But again, this might change because as the population grows, as development increases, as growth of populations and cities and countries increases, then of course you will expect a higher level of energy consumption. But if we keep the level of energy consumption at the current levels, then this energy source, if we are able to extract them safely, will last us a long time. So we will have to worry so much where we are going to get our next energy resource. On the other side, that's why you can see that the boxes are now in red. Despite all the advantages that can be derived from extraction of gas hydrates, there's the flip side. And the flip side is one, if this gas dissociates, so if it becomes unstable at the depths where it is located, for example, especially in water depths of greater than 300 meters, when the gas dissociates from its from its water lattice or from the water cage, then it may cause slopes in the seafloor to become unstable. And when they become unstable, there is a potential for submarine slopes to collapse. When they collapse, they can trigger landslides, and sometimes these landslides can generate tsunamis. So it's not only earthquakes that are capable of generating tsunamis. If you have submarine landslides and if the displacements are large enough or big enough, then they can also potentially cause um, landslides. Okay. The next bullet or the next box says that it can contribute to global warming if it is released accidentally. So this is one of the more significant and challenging questions posed when it comes to studies of gas hydrates and what technologies we can propose to safely extract gas hydrates. So if you accidentally puncture the gas hydrate zone without careful extraction of the gas hydrate, then the amount of methane that it can potentially release into the atmosphere is much, much worse than what we're experiencing now. So the global warming that we're experiencing now, the climate change that we're being subjected to now is only because of anthropogenic contribution. So it's man-made contributions, the industrialization, the introduction of cars, factories, vehicles, etc. So all of those contributions can be minimized if you accidentally puncture a gas hydrate zone and release large amounts of methane into the atmosphere. And then the third challenge is, as I said, what are the safe technologies that will allow us to safely extract gas hydrates so that they're not accidentally released into the atmosphere, so that we can safely harness the carbon that is trapped within the gas hydrates and safely use that as our potential energy source. So what do we know about gas hydrates and where are they formed? So most studies indicate that gas hydrates form when methane and water combine, and we can clearly see that based on the structure of the gas hydrates. So earlier we saw the structure where you have a water cage, and inside that water cage is the gas molecule in the form of methane. Most studies indicate that the requirement to form gas hydrates is low temperature, but moderate to high pressure conditions. And the moderate to high pressure conditions, we satisfy this when we go to relatively deeper depths in the offshore areas, for example. And the more common occurrences of gas hydrates are typically in permafrost regions, In the permafrost regions, they occur at relatively shallow levels, but in the continental margin settings or where you have convergent zones, this is where you find the gas hydrates to be at deeper levels or deeper water depths. So this is where the challenge comes in when trying to extract offshore gas hydrate deposits. So this is just a cartoon diagram that shows you the two regions that are favorable for the formation of gas hydrates. So these are permafrost regions where Arctic methane hydrate deposits may form above and below the lower limit of the permafrost. So here in some onshore areas, like in the Arctic region in Western Siberia, they have already been starting to commercially produce gas hydrates. So this one, because of its shallow level, the technology is not as challenging in extracting the gas hydrate. Unlike when we talk about gas hydrates in the offshore areas, so here you have to deal with water depths of greater than 300 to 500 meters. You can have your methane hydrate deposits occurring or forming below the seafloor. Aside from these two areas, there are also two types of methane that form the gas hydrates. So one is known as biogenic methane, and this is simply produced when you have microbial activity in the upper section of sediments. So this is what we typically see in permafrost regions. And then the other kind of methane is the thermogenic methane. This is what we typically see in the offshore deeper areas. So this refers to the thermal breakdown of organic materials at great depths. So in both cases, you need organic materials. In the biogenic case, you need microbial activity in order to form the gas hydrates. So one of the requirements to form gas hydrates, as mentioned earlier, is the presence of low temperature but moderate to high pressure conditions. So this requirement of the pressure and temperature conditions dictates at what depth and at what level gas hydrates can form. So this region where gas hydrates are stable is referred to as the gas hydrate stability zone. So that's the GHSZ. So in this diagram here, you can see that beneath the seafloor, you will have to look for the optimum conditions in terms of temperature and pressure. So here you see the temperature. You have to look for the temperature and pressure conditions which will allow gas hydrates to accumulate. Okay, so here you can see that the temperatures are not really very high. So they're just from around between 0 and 20 degrees centigrade. So what we need to see is the pressure conditions, and that will be also dictated by the depth at which the gas hydrates form. So typically in marine settings or in the offshore areas, the zone of potential gas hydrate occurrence is known to start from the depth of the seafloor until the base of the gas hydrate stability zone. So this is the most important aspect of gas hydrate formation that will help us when we try to determine where to look for gas hydrate. So ito yung clue that we need to look for. We need to find the base of the gas hydrate stability zone. So again, how does one look for gas hydrates? We know that gas hydrate formation is prolific within active margins. These areas, active margins, meaning where you have subduction zones or where you have two plates colliding with each other. So this is what we call an active margin. And this is one of the favorable sites for gas hydrate formation because you have methane generation in this region and you have the upward expulsion of fluids. So these are the conditions that may be present within the deeper areas within your active margin settings. So these are things that we need to look for. In offshore areas, you have gas hydrates forming above a free gas layer. Okay? So why do we look for gas hydrates within active margin settings or within subduction zones? Because here, the requirement for temperature is going to be satisfied. So the heat flow is a little bit higher towards the trench and forearc region. It goes down when you get to the forearc portion, and then it goes up within the arc portion. But within this subduction zone region, then the optimum temperature conditions are going to be satisfied. So we need thermal gradient, we need heat flow. That is one of the ingredients that we need to be able to form the gas hydrates. So this is again within the permafrost region. So just to show you that this is the top of the hydrate stability zone, you will need to look for indicators of the top and bottom of the hydrate stability zone. So here, this yellow region here shows the hydrate stability zone, and this is where gas hydrate is most likely going to form. But beneath the hydrate zone, you can see that free gas is going to be present underneath that layer. If we look at the active margins, like the convergent margins, margin settings, and the deep marine areas, then we will also need to identify where the hydrate stability zone is. And beneath that, again, is a free gas layer. So how do we start to do gas hydrate exploration? The first thing is we have to define the depth at which the base of the gas hydrate stability zone occurs. Now, this base of the GHSZ is usually identified or delineated by looking at seismic reflection data. So we define the base of the GHSZ using seismic reflection data. So this is one of the key methods, key geophysical methods. If you want to look for gas hydrates, or if you want to do gas hydrate exploration, you will have to do seismic reflection surveys. If your targets are in the offshore areas, then you will have to do marine geophysical surveys. So here, I'm going to intersperse or introduce a little bit what geophysics is about, because as mentioned a while ago, this is one of the key techniques and key methodologies if you want to look for gas hydrates. So what is geophysics? Well, one of the earliest versions of a geophysical method. If you're familiar with the what you see on the drawing, what does this look like to you? This method of looking for water centuries ago. Paano bang naghahanap ng tubig a long time ago? Have you heard of the term water witching or water dowsing? 'Di ba? A long time ago, sabi nila, people looked for water, groundwater, by walking around with a twig branch or a branched twig stick. And then they said that when the stick points downward, then that supposedly indicates where the water is. So this is like the earliest version of a geophysical technique, although of course this is not geophysics per se, but the principle behind it is quite similar. So geophysics is not like walking around with a metal detector and then just saying na, okay, the metal detector sounded, made a large noise or made a loud noise, and then therefore I know it tells me that this is where the gold is, for example. That is not what geophysics is about, okay? So what we do with geophysics is you have to carry out a geophysical survey, meaning you have to operate an equipment, and that equipment measures physical properties that are related to the mineral deposits or energy resource deposits or groundwater deposits that you are trying to look for. So what geophysics does is try to see beneath the surface, kasi hindi naman natin nakikita where the deposits are that we are looking for. They are underneath the Earth's surface, and therefore we need a tool that will allow us to see beneath the Earth's surface. So with geophysics, we use various equipment and instruments, and those instruments provide us with clues that point us to the features that are related to the mineral or energy resources or groundwater resources or geothermal resources that we are trying to look for. Okay? So geophysics more often than not does not directly lead you to the, or does not directly allow you to see the deposit that you're looking for, but what it does is it allows you to look for the clues that you need in order to find the deposit that you're looking for. Okay, so para siyang search for a treasure. In order to look for the treasure, you need to look for clues. Yung iba may map, but yung iba may mga indicators that will lead them to find the treasure. So this is what we try to do with geophysics. So these are just some of the equipment, geophysical equipment that we have at the National Institute of Geological Sciences. And we have acquired all this equipment through our DOST funded projects. So this equipment that we use for various targets, for various purposes, uh, allow us to obtain measurements, but those measurements do not immediately tell you where the deposit is that you're looking for. You have to interpret or process the numbers that are produced by the equipment and the instruments that you are using, and a careful processing transforms these numbers into what we call anomalies. And these anomalies are the things that allow us to get clues about the features that we're trying to look for. So here we have now a variety of equipment. So we have an equipment that we can use to do gravity surveys, magnetic surveys. This is our version of a GPR. I'm sure if you will Google a GPR on the internet, you'll see different types of models, different from what we have here. This is a traditional electrical resistivity meter. This is a seismograph, and this is a multi-electrode electrical resistivity induced polarization equipment. So we have various equipment that can be used for various targets. So as I said, geophysics, with the equipment that we have, those equipment allow us to measure or detect variations in physical properties. So we need to be able to detect contrasts in physical property, and these contrasts, when we interpret them and when we correlate them with the geology of the area, this will give us clues on the features and the deposits that we are looking for. Some geophysical methods only are able to detect vertical contrast. So if you have horizontal layers, for example, like this, then you can distinguish one layer from the other to the other and get estimates of their depths, their thicknesses, etc. Other equipment or other geophysical methods are only able to detect lateral physical property contrasts. So in order to produce a geophysical anomaly, kasi it's the geophysical anomaly that we want to interpret in terms of the features that we're looking for. So here, some examples of geophysical methods show only their capability to detect lateral changes to be able to produce a geophysical anomaly. The physical property that I'm talking about simply refers to these physical properties listed here. So one is density, which we all know to be mass per unit volume. The other one is magnetic susceptibility. It just tells you how strongly a material may be magnetized. The next one is acoustic impedance, which just tells you the velocity of the seismic wave, which is affected by the density of the material through which the wave travels. This acoustic impedance is something that you will have to keep in mind because this is what we are going to be looking at later on when we try to look for gas hydrates using seismic reflection methods. And then, of course, we have rocks and minerals which are able to transmit electricity. So in that sense, we look at their conductivity. There are also materials that are able to transmit radar energy to depth, and that property is known as dielectric constant. And there are materials, rocks, and minerals that are able to retain an electrical charge, and we call that chargeability. So these physical properties are the parameters that are being measured by various geophysical equipment. So yung geophysical equipment, they produce numbers. Those numbers will have to be processed, interpreted, analyzed, and correlated with these different physical properties. And that will tell us what could possibly be found in the subsurface. Because when we do geologic mapping, we see what is on the surface, but we don't know what is in the subsurface. So it's the geophysics that provides us with various information about the subsurface. So geophysical surveys can be carried out in different modes of data acquisition. So if the targets are offshore in the marine areas, then you will have to do a marine survey. If the targets are very large areas and which you need to cover in a relatively small amount of time, then you will have to do an airborne survey. Some innovations have been developed to do the survey faster and faster, quicker, but getting a substantial amount of data. That's why you can see this variation of a magnetic survey using a bicycle. Unmanned aerial vehicles or drones have also featured um, significantly when it comes to innovations uh, in how we do geophysical surveys, but this is not applicable for all geophysical methods yet. It's being done now to acquire magnetic data, but not the other geophysical data. And of course, all the other geophysical data that we have can be used in a ground survey. So that's what you see in these photos at the bottom. So again, geophysics just means we try to recall all the laws and principles of physics that we learned in our physics courses. And then with those principles of physics, we try to relate them in order to get clues about the Earth's structure, the composition, meaning the rocks, minerals, deposits, and as well as processes. And if you will recall, the way that we learned about the layered structure of the Earth, the interior of the Earth, is because of the study of the seismic waves. How seismic waves traveled from one point to the deeper portions of the Earth and how they were detected or recorded by various seismic stations in different parts of the Earth. So because of the velocities and behavior of seismic waves, scientists were able to propose this layered structure of the Earth. And because of the velocities, we were able to get an idea what the compositions are, how the compositions vary from the crust to the mantle to the core. So that's why we know in the crust, it's mostly silicon, aluminum, silicon, magnesium. When you get to the mantle, it's mostly iron, magnesium. When you get to the core, it's iron, nickel. So geophysics has helped significantly in terms of imaging the Earth's interior and its layered structure. So focusing on the seismic reflection method, our discussion is going to be on this method because this is what has been very useful in the search for gas hydrates. So this is one of the geophysical methods that I was referring to earlier. So the principle here is that you need to trigger seismic waves. So that's what this person is doing by hitting this hammer on this metal plate. When that hammer comes into contact with the plate, it's going to cause seismic waves to travel from this point to the subsurface to the deeper levels. But when the seismic waves encounter a layer, that layer may be due to differences in the physical properties between the sediment in the overlying layer or the rocks in the bedrock in the deeper layer. So this is what we mean by having a physical property contrast. So obviously, for example, here, the density of sediments in the overlying layer is going to be different than the density of the bedrock in the deeper layer. So because there is a density contrast, then that is going to cause the seismic waves that are traveling to be reflected back to the surface. So travel, 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 back to the surface, travel, travel, back to the surface. And you have to have a series of recorders or receivers, which we call geophones. And what these geophones do is that they are the ones that sense or detect the arrivals of seismic waves. Okay? And the arrivals of the seismic waves are recorded in a seismograph. So the principle of the seismic reflection, based on physics, we have learned that if you have an incident wave which gets reflected, well, the angle of incidence is equal to the angle of the reflected wave. So again, a seismic wave is reflected whenever it encounters a physical property contrast. Okay, so that's a key factor in detecting an anomaly, which is what we want to see when we do geophysical surveys. So just to give you an idea, if you want to do a seismic reflection method, as I said, we need a source. The source is what triggers the seismic waves. So dun sa earlier figure, it was the person striking a hammer on a metal plate. But there are other various forms of sources that can trigger seismic waves. Some of them can include explosives or dynamites. Some of them can include trucks, this like big trucks like here, which thump the ground, and when it hits the ground, then it triggers seismic waves. So the next component in the equipment that we need is the receiver. So these are the ones that detects the seismic waves. So these are the geophones that are shown here in orange below. And those are the triangle things that you see here on top. So they are the ones that detect and record the arrivals of seismic waves. And then all of this information is being recorded in a seismograph. Okay. So if you're going to do a marine seismic reflection survey, that means you will have to have a research vessel. The seismic source when you do a marine survey is known as an air gun. What the air gun does is to release a high pressure bubble. And of course, since it's a bubble, once the bubble pops, then it's going to release energy and cause seismic waves to travel down to deeper levels. So again, here, you see boundaries here between young and old sediments. The young sediments will be less dense, the older sediments will be denser because there are differences in the densities. Then those densities will affect the velocities of seismic waves. So therefore, it will cause seismic waves to be reflected back to the surface. And this will be detected by what we now call a hydrophone streamer. So kanina, geophone because it's on land, but when you do a marine survey, then you call the receivers hydrophones or a hydrophone streamer. And this is towed behind the research vessel and kept at a certain depth below the sea surface. Okay? So this is the principle behind a marine seismic survey. This is how we typically collect seismic reflection data in offshore areas. So again, this is the photo of the survey vessel. This is the seismic source. It causes seismic waves to travel. It hits different layers, different layers, different layers, and all those layers will be recorded by the geophones, which are stored here in the streamer cable that you see in the lower right panel, the one in yellow. So that is stretched behind the research vessel. So ito yan. So that is what it looks like. Inside it are the hydrophones or the receivers. This one is the source array. This is the air gun that releases the high pressure bubble. And then when it pops, it's going to release seismic waves. In our case, in 2022 and 2023, we worked with some Taiwan collaborators in order to be able to do a marine seismic reflection survey. In the Philippines, we don't have a research vessel that is capable of doing marine seismic reflection survey. So that's why we have to collaborate with our scientists from Taiwan. Um, they have the capability, they have the equipment, they have the research vessel. So we help bring them in so that we can acquire the geophysical data that we need from the Manila Trench. So this was the research vessel that was used during the 2022 and 2023 marine geophysical surveys. So the data that is acquired during a marine seismic reflection survey looks something like this. But this is raw data, so that means that the scientists will have to do some processing, some applications of filtering, other techniques that will help clean up the seismic section. And you want to do some processing because your end goal is to come up with a seismic section that looks like this, what I'm showing on the slide now. At this scale, you might think you don't see anything, but if you look at it closely, then there are some features there that will allow scientists to interpret them. You can see here on the left panel that you can see some lines or linear features. So those look like sediments, di ba? Sediments natin yung nagpo-produce ng layers. You see the same thing here in this portion. You see almost horizontal lines in this portion here. But in other portions, these are quite disturbed and the lines or the reflectors are quite chaotic. But our scientists are trained to look at them carefully and see what other features can be uh, delineated, just examining those seismic sections. So we thought of looking for gas hydrates within the Manila Trench. Why? What prompted us to think that there might be gas hydrates within the Manila Trench? You will recall earlier that we said that one of the favorable sites for the formation of gas hydrates are active margins or convergent margins or subduction zones. So we know that the Manila Trench is a subduction zone. Therefore, that is one area where we could potentially find gas hydrates. The other thing is that, particularly in Taiwan, they have been doing a lot of gas hydrate research for the past years already, way before we attempted to do studies of gas hydrates. And in their studies, these three dots here indicate that they have found indicators or evidence that gas hydrate is present within the southwest Taiwan margin. And you can see that southwest Taiwan is very close to the Manila Trench. So the work that we did was for the Manila Trench area here. So if they were able to find gas hydrates in southwest Taiwan, given the similarities in the geologic configuration between Taiwan and the Philippines, then maybe we also might potentially find gas hydrates within the Manila Trench. So they also use seismic reflection data similar to what's being shown here in the upper panel. And they were looking for indicators of gas hydrates that are known as BSRs. I'm going to explain that in the next slide. So here, this is our Taiwan collaborator, Professor Shukun Su, and they were able to actually collect an actual sample of a gas hydrate. So this is what it looks like when it burns, but it's a clean version of an energy source. So aside from that work in Southwest Taiwan, which already indicates the potential presence of gas hydrates, there were also some earlier studies within the Manila Trench region that already reported the presence of BSRs or bottom simulating reflectors. Bottom simulating reflectors are our clue to the gas hydrate. That is the clue that we need to look for in order to indicate whether gas hydrates are present or not. So these two earlier works have already reported BSRs. However, although they reported the presence of these BSRs, they did not do any further systematic study of gas hydrates. They simply reported it, but they did not do any further studies beyond reporting the BSRs. And in our case, knowing that we have several data sets of seismic reflection data that have been collected in various marine cruises within the Manila Trench region. Then we decided we have a treasure in terms of the seismic data that is available to us that we can potentially look at when we try to examine and look for clues for the occurrence of gas hydrates. So here we have a 1980 marine geophysical survey done by the German scientists, American scientists, RV Vema. The 2008 Sonic cruise was carried out by German scientists with some Filipino researchers. The 2014 RV Ocean Researcher is the work that we did with our Taiwan counterparts. And then we had the 2022 marine survey using that vessel, that newer vessel of Taiwan. So all these lines here show where seismic reflection data were collected. So you can see that there's a vast wealth of information in terms of the data that is available. So that's the reason why we thought of looking at examining those seismic data. So I was already mentioning BSRs earlier. So most scientists indicate that the clue to the presence of gas hydrates are BSRs. So BSRs are bottom simulating reflectors. And why do we need to look for BSRs? Because this supposedly corresponds to the base of the gas hydrate stability zone, which I explained earlier. So we need to determine the base of the GHSZ, and that base of the GHSZ is delineated or defined by a BSR. So a BSR, what is a BSR? We earlier said that we need to look at physical property contrasts. Okay? So if a seismic wave travels from an ocean to the sediments, then from a less dense material to a denser material, it's going to produce a reflected wave, and that reflected wave is going to produce a positive response. Kasi mas dense yung nasa ilalim, less dense yung nasa ibabaw. So therefore, it is going to produce a positive impedance. However, in the case of gas hydrates, as mentioned earlier, the gas hydrate intervals above are denser kasi nga because of that water cage or water molecule cage. So they're denser. And then underneath, you have free gas, and free gas is less dense. So the seismic wave travels from a denser material to a less dense material, and therefore, what it displays instead is a negative impedance. Okay, something that looks like this. So since you're transitioning from a denser gas hydrate zone to a less dense free gas interval, then it is going to display this negative impedance. And when we look at the seismic sections, then the BSR is going to be something that looks like this. Itong tinuturo ng pointer. So we look for a negative impedance reflector as our clue that above there's a gas hydrate zone and below there's a free gas zone. So that is what we set out to do when we examined the seismic reflection data from the Manila Trench region. So these figures that I'm showing here on the right are taken from this small survey line here, which is very near the Manila Trench. Okay, so the Manila Trench is this portion here. And then within the 4-arc region, they were able to collect a seismic reflection data, and this is what it looks like. Okay, so if you zoom into this portion here, and that is that portion here below, you can see this very distinct reflector, which we characterize to be showing a negative impedance. Okay, so this reflector here is what we call the BSR. Yeah. So this panel on the right is the interpretation already. So ito yung drawing natin of what we can see from this seismic section. So here, this is the BSR that we have delineated. Aside from the BSR, we were also able to delineate some faults. So the interpretation here is that it is a thrust fault. And then there are also some features which we interpret to be gas chimneys. So ibig sabihin doon umaakyat yung gas and they are able to reach the seafloor when they are expelled through the gas chimneys. Okay, so this is one section that we examined, that we identified and interpreted, where we were able to see or delineate the BSR. And then we also looked at this line here. Okay, this is another line that we interpreted. Again, this is the seismic section for that entire length of the line. But we zoom into this portion here because we have examined this already previously. And in this portion, the BSR that we delineated is this reflector here. So you can see it's a linear feature, negative ang impedance or baligtad yung contrast nung densities niya. So this is the interpreted section here. So that feature is what we refer to as the BSR. Again, above should be the gas hydrate horizon and below should be the free gas horizons. And again, for this particular seismic section, may na-delineate din kaming fault, and I think this was interpreted to be a strike slip fault. And then if we go further south of the Manila Trench, ito naman, further south, already near the, ano ba to? Subic, Bataan area here. Okay, so this seismic line is a little bit longer, but again, our emphasis is only on this portion of the seismic section. So this is a close-up of that portion. And we see several strong reflectors, which we are here, this one, which we are interpreting to be the BSR. Okay, so aside from the negative impedance, I failed to mention that the BSR mimics or mirrors the seafloor. So ito medyo parallel siya or medyo similar ang itsura nung BSR sa seafloor. So here we interpret this to be the BSR. This one is the gas hydrate zone. Below are the free gas. But take note, in this particular section, if we're going to zoom into a particular portion, we were able to identify several normal faults for this area. So madaming normal faults na nakikita. So we looked at several other lines. I'm not going to show all the lines anymore, but we looked at several lines kasi nga madami namang available data sets. And based on the survey data that we examined, northern part, we saw here, we were able to identify BSRs. For the West Luzon Trough, this region here, we were also able to identify BSRs. So you can see here that they're present here, present in the North Accretionary Prism here, present in the North Luzon Trough here, and present in the West Luzon Trough. The depths at which they occur vary. So it's relatively shallower here in the northern part, and in the West Luzon Trough here, the BSR depths are from around 300 to more than 1,400 meters depth below seafloor. So it's very variable. It's also very interesting to note that there are possible fluid migration structures, meaning if there are cracks in the rocks in the subsurface, then some of the BSR could potentially, or the gas could potentially migrate or escape through those cracks. Kaya that's the reason why I also was pointing out the thrust faults, the normal faults that were delineated in some of the seismic sections. So as reported in some of the news features that reported our work, based on the presence, based on the area where we reported the BSRs, then we think that there's a big exploration playground for those who would potentially do further work to examine and confirm the presence of BSRs. We have more than 12,000 square kilometers of area that we can explore and examine more carefully. But at least with the work that we did, if somebody is keen on pursuing gas hydrate studies in the Philippines, then you would not need to start from scratch, meaning you don't need to image the whole region. But with this work that we have done, you could potentially start looking at these areas first where the BSRs have already been reported. So, as I said, masyado tayong late bloomer when it comes to gas hydrates. When I was doing my PhD way back in 1997 to 2001, a lot of the other countries were already aggressively exploring gas hydrates. Japan was very aggressive at that time, the United States and some of the European countries. So I think this map was generated in 2005, where they were first reporting potential gas hydrate accumulation. So you can see all the red dots are the areas which reported possible gas hydrate accumulations. However, in 2018, you can see that aside from reporting the pero dito, we're now going to include the Philippines for the recent work that we have done. So from 2005, this one I think is 2018 map that shows na beyond reporting the presence of gas hydrates, some countries, those in yellow dots, have already recovered hydrates, meaning they have attempted some technologies that allow them to extract samples. Um, some are still at the inferred hydrates, meaning they have not yet gone beyond um, the seismic reflection surveys and identification of BSRs. So inferred pa lang, maybe reports pa lang, hindi pa proven. To prove whether the gas hydrates are really there, then you will have to do drilling. So this is the same thing that we need to do for the Philippines. Finally, we will include the Philippines for reports of potential gas accumulation. But beyond the reporting of the potential gas hydrates, the next step will have to be further studies. And aside from that, drilling will also have to be done. So you can see here that some countries have already been in the advanced stage of their gas hydrate exploration work by doing the drilling, and some of them have gone further by doing recovery of gas hydrates. So again, still the potential, the interest in gas hydrates is um, very keen, especially because of the resource potential that's being reported. So here, this is the work done by the United States Department of Energy. This is a very conservative estimate. Yung kanina, I was saying some were projecting that the supplies will be good for 200 years. In this report by the United States Department of Energy, they're saying it's capable of supplying um, or contributing to future energy systems for the next 10 to 20 years. You can see which areas or which countries have larger resource potential for gas hydrates. So it's the Arctic region because of the permafrost. So as mentioned earlier, this is one of the more favorable sites for the formation of gas hydrates. Kaya maganda yung potential nila. And since this is onshore, then therefore it's not as challenging to recover and produce gas hydrates from the permafrost regions. The United States also has or holds a large resource potential for gas hydrates. Same thing for South America, and of course in all these other countries. Within the Asian region, Japan is at the most advanced stage of gas hydrate exploration, and China, of course, is not so far behind. Uh, But as I said, we need to understand what are the same way that you do exploration, development, production for oil resources, gas resources. These are the stages for oil and gas. I'm assuming that it's a little bit similar for gas hydrates. So in some cases, exploration may be 2 to 6 months if you are doing continuous exploration work. But going into the production stage may take another 2 years, and further going into the commercial production stage is going to take another 20 years. In this exploration program, the estimate is 5 to 10 years from discovery to evaluation, another 15 to 30 years from development to production, and then to subsequent abandonment. So as I said, us reporting the potential presence of gas hydrates in the Manila Trench region, we're still at the very, very starting line pa lang. We are far, far off, far, far away from developing and producing the gas hydrates in the Manila Trench region. So I think the Malampaya was discovered in I forgot, 1985, but it took more than X years before it can be subsequently developed commercially. So you have to put yourselves within that frame of mind that reporting the potential presence is at the initial stage. We will still have to do a lot of work before we can go to confirming the presence of those gas hydrates, further evaluation before we can even proceed to development and subsequent production of the reported gas hydrates within the Manila Trench region. So how are the other countries faring so far when it comes to gas hydrate development, production? So here you can see this figure for the deep water marine gas hydrates. Again, Japan was initially at the forefront. Sila yung isa sa earliest that reported gas hydrates. They were one of the first to do production testing that they have completed. And then you have the USA following behind, Korea, and then China is also catching up. And they have been doing some press releases that they have successfully conducted pilot or trial testing. It remains for us to see whether they have progressed towards commercial production of gas hydrates. Again, for the permafrost regions, it's a little bit easier for extraction of gas hydrates in these regions. So therefore, you can see Canada has, in a short span of time, done production testing already. The same thing for the USA. So this is what I was saying. China has been issuing a press release. I think this was 2017, this photo, when they were reporting the successful conduct of trial production testing for this deposit that they found here at the southeastern margin of China. So yan ang kanilang press release. So they are claiming that their discovery of the combustible ice or the gas hydrates in the South China Sea started in 2007. Their professional research officially started in 2011. So they're claiming a shorter amount of time compared to the US, where the combustible ice research project started in 2000, but it was only in 2011 when they did ice extraction in Alaska. So parang they're showing off that they can do it in a shorter amount of time. The same thing for Japan, which was supposedly one of the earliest to find gas hydrates, but only mastered the skill of deep sea methane separation only in 2030. So again, this is the press release of massive ah, ah, this one pala, again, aside from the safe extraction of gas hydrates, which is one of the technological headaches of those wanting to develop gas hydrates, people are also monitoring now accidental releases of methane gas. And in 2020, they came out with a report that there has been massive release of methane gas from the seafloor that was discovered in the southern hemisphere. So even without doing anything, accidentally nare-release yung methane gas from gas hydrates in the deeper levels when there is dissociation. So when the gas molecules and water molecules become unstable, they are accidentally released. So if they go through cracks in the subsurface, then they might find their way into the atmosphere in the upper levels. So some are trying to examine whether this massive release of methane gas in the southern hemisphere has also contributed significantly to the global warming and climate change that we're experiencing now. So this is one of the recent studies regarding the accidental releases of gas hydrates. So I think in your case, for your studies and for the course that you are in, I think one research topic that you should be looking into, because this is now where really the challenge is when it comes to gas hydrate exploration and development, is the recovery method or mechanism. What technology will allow us to safely extract the gas hydrates from from deeper levels and then extract them safely without causing any accidental release into the atmosphere so that it contributes to global warming. You also want to maintain the pressure temperature conditions stable, because any changes in the temperature conditions might cause the gas hydrates again to become unstable and to dissociate. So those are the challenges in terms of the technologies. Although in some recent publications, these are the possible gas recovery methods that they are proposing to extract gas hydrate. I'm not familiar with these techniques. Maybe you are more familiar with this. So just so you know, they're looking at thermal injection, inhibitor injection, and depressurization. So if this is something that's of interest to you, then these are papers that you might want to take a look at and see what developments and what improvements have been made when it comes to the technology to safely extract gas hydrates from the deeper levels, especially in marine areas or offshore areas. And I think with that, I am finished, and I am more than happy to answer any questions that you might have.
Thank you for that informative discussion, Dr. Di Malanta. Now let's open the floor for questions. You may raise your hand virtually or type your question in the chat box. So, anyone? So we do have a prepared questions for you, ma'am. So I think this is from Jules Florendo. Upon reading your paper po, by the way, thank you for giving access sa ResearchGate. The active tectonic setting introduces uncertainties from these equilibrium conditions not fully explored. What geomechanical modeling have you performed, coupling for pressure transients, fault valve behavior, and time-dependent hydrate stability to assess how cyclic deformation may impact predicted hydrate distribution and interpreted migration pathways over varying time scales?
Okay, so that's a lot, diba? It's a mouthful of questions. As I said, we're still at the very, very, very young age of gas hydrate exploration. Lahat ng tanong mo are things that will have to be examined, not by us, but by other scientists and engineers. For example, the geomechanical part is something that we don't have the expertise on. We did, our student, Alicia, did thermal calculations or heat flow calculations, kasi nga we wanted to see at what depths these gas hydrates occur. But the instabilities and other conditions, we have not looked into that. As I said, we're still at the very, very initial stage of the studies. So just reporting that gas hydrates may be present is the first step. All those things that you ask, all those things in your question are all the things that our students, our researchers might have to do in order to, if we get to the point that we're going to extract the gas hydrates, then we should know more about these conditions. Kasi tama kayo, the thermal stability is important kasi nga it's affected by temperature and pressure. So we will really have to examine what are the stability conditions of these gas hydrates. So those are topics, interesting topics that future scientists, students like yourselves, other researchers might want to work on.
Okay. So, another question. In what ways did the bathymetry data enhance the interpretation of seafloor features in the offshore Western Luzon region?
Well, mostly the data that was used to look for gas hydrates is the seismic data, multi-channel seismic data. The bathymetric data, we just examined the bathymetric data just to see in which portions of the seafloor or what bathymetric features may be considered when we look at the locations of the potential gas hydrates accumulations. Do they prefer to be formed within the trough or the parang basin portions of the Manila Trench, or are they found more in the accreted sediments? So that's the reason why we also examined the bathymetric data. If you will look at the West Luzon Trough, the southern portion where we reported the gas hydrates, well, maybe it was also a function of where the seismic lines were, kasi we had to depend on what's available to us. Madami kaming seismic lines na nakita doon sa West Luzon Trough, doon sa southern part. So maybe that's the reason why mas maraming data kami na nakolate. But like I said, the bathymetric was just to help us understand the seafloor topography that might contribute to where we could potentially find the gas hydrates.
Thank you so much, ma'am, for answering. So, another question. Regarding resource appraisal, aerial distribution provides minimal insight without saturation constraints. What well-tied reservoir simulation integrating poroelastic well logs, NMR profiles, and rock images were run to properly calibrate fluid volumes before proposing such vast accumulations?
Again, we don't have any drill data. We don't have well data for the Manila Trench. Okay, particularly for gas hydrates, there is no well data that is available to us. So again, we are not able to provide any further information regarding the properties, regarding all those things that you mentioned. Kasi nga typically, di ba, when for oil and gas resources, once you report oil and gas, you do the drilling, you collect the well data, and then you are able to characterize all those things. As I said here, it's not very simple. Although we know that we need to drill, we need to know how to drill, where to drill, because we don't want to accidentally puncture the gas hydrate zone. So medyo I'm not yet sure if the drilling for gas hydrates is as similar as what we see na drilling for gas resources. Baka may konting tweaking of the drilling. I'm not sure because we don't want to puncture the gas hydrate zone and cause it to accidentally escape into the atmosphere. So wala pa talaga kami to that point of uh, ascertaining those conditions and properties.
Thank you, ma'am. So next, so could you provide insights to elaborate further into the implications of the geothermal gradient values calculated for methane seepage and gas hydrate occurrences in the study area?
As mentioned, we need to look at the thermal gradient. Okay, for the various sections that our students looked at, they had to do heat flow calculations so that we can try to estimate at what depth these gas hydrates may be found. Aside from the heat flow calculations, we were wanting to see heat flow data as well. But again, we don't have a lot of heat well data that's available in the Manila Trench area. There are some, but it was difficult to correlate them with the presence of gas hydrates kasi medyo malalayo yung locations ng heat flow data. So we did do some thermal calculations, but they were just based on the depths at which the BSRs were found. Again, nothing further, nothing more elaborate than just establishing or just defining the BSR and at what depth they are found. And then with the depth, just correlating or computing the heat flow data. So yung thermal gradient, tama yung sinasabi nyo, it's important to consider that kasi nga yung gas hydrate stability zone will be affected by the thermal gradient, the geothermal gradient. So it was important for us to pinpoint the heat flow conditions and the depth conditions in order to ascertain na favorable siya for the formation of the gas hydrates. Again, nothing beyond that. This is all initial stage. This was only also just part of a research work that we did. It's just a 1-year research work that we did. So we have not yet progressed beyond that initial stage of reporting the possible presence of gas hydrates.
Thank you, ma'am. So for our fifth question, the study area is described as heterogeneous, yet tectonic controls on fluid flow are generalized. How do variations on structural or stratigraphic settings, such as migrating thrust, change in wedge or basin sediments, influence predicted fluid pathways?
The area is described as heterogeneous because there are a lot of features present within the Manila Trench region. So from the northern part to the southern part, the characteristics of the seafloor, the amount of sediments on the seafloor, the thickness, how wide the trough is, these are very variable. We need to look at all these features again to see whether the presence of faults, what the role of those faults will be when it comes to the presence of gas hydrates, whether they can act as fluid escape paths. We reported gas chimneys that are supposed to be reflected as gas ridges or pockets on the ocean floor. So all of those things have to be assessed in terms of whether they will allow gas to escape to the seafloor and to the atmosphere, or whether they will act as parang potential traps or reservoirs or sealing materials for the gas hydrates.
Thank you. So we still have a lot of questions. Can you still accommodate it, ma'am?
Sure.
So for the next question, given active deformation and seismicity, what level of disequilibrium should be expected from transient conditions? How might this impact proposed models of hydrate formation?
Any instability will have to be carefully examined kasi nga sea surface temperature changes, some studies are saying that sea surface temperature change will affect also the temperature, the heat, the thermal gradient and the heat flow conditions in the area. So lahat yan need to be examined carefully. Ano pa yung tinatanong mo? Heat flow,
How might this impact, ma'am, the proposed model for hydrate formation?
because gas hydrates are stable only under certain conditions. So any changes in those conditions will make them unstable. So again, examining how much change will not affect the gas hydrates is important. How little or how much the change should be is something that we want to see, because this is going to impact whether the gas hydrate is going to accidentally be released or will dissociate. If it dissociates, it's going to cause slopes to become unstable. They may cause landslides, they may cause tsunamis, and so on and so forth. So again, there's still a lot of studies that we need to do. With this work of reporting gas hydrates, ayan, madami kayong tanong, that is very good because that is the next direction of, that is going to be the next stage of this work on gas hydrates. All those questions that you're posing now are really valid because this is where we should direct our interest in for those who are doing studies on gas, energy resource potentials. These are the questions that should be asked if the gas hydrates are something that we really want to develop. It's not just among us I mean, it's not, yung sa amin kasi it's out of curiosity lang when we did the work. But if the government decides to really commit to doing gas hydrate exploration, all these questions that you're asking are all the questions that need to be asked in order to develop gas hydrates for the Philippines.
Thank you, ma'am. So we have a question in our chat box from Mr. Gabriel Malasique. Hello, Dr. Carla. Since there's seismic data, then it might be possible to create a geological model from it. Are your raw seismic data available to the public?
Raw seismic data they're not available to the public. Unang-una, even if it's available to the public, it cannot be processed just by any laptop or desktop computer. It needs a specific software that allows processing of seismic reflection data. So what is typically available to the public are the processed seismic data. Some of those figures that I showed earlier, yung madaming mga lines. Some of those are processed, some of those are published. And once it's published, people can look at it and work with it to maybe, like you said, develop models out of the seismic data that's available. So only the processed seismic data is available. The raw data are typically, if you request it, maybe you might get it, but typically it's not made publicly available.
I hope that answered the three questions, Mr. Malasique. Okay, so for another question, ma'am, what future research directions or studies do you envision based on the findings and methodologies employed in your study?
Lahat ng questions na sinabi nyo kanina, those are the future directions. Kasi as I said, nandun pa lang tayo sa umpisa, marami pa tayong kailangan gawin in order for us to know if we can harness the gas hydrates within the Manila Trench, what are the conditions, what are the stability fields that we need to know, what are the gradients, all of those things, those are the future directions. So as I said, with this report, we hope it opens up all those things to future research in the Philippines. And sana ma-recognize ng government that this is a research potential that needs the attention of the government, especially in terms of funding. Not only the exploration, but the technology, especially in your case, yung mga petrophysics and so on, di ba? All of those things will come into play only if the government is serious about tapping gas hydrates as an alternative energy source for the Philippines. Kasi kung tayo-tayo lang, well, we can do our academic studies, but we need to go beyond that. So if you need to go beyond that, then you need more resources in order to do further research, especially for topics like gas hydrates. Medyo it's an expensive research endeavor.
Okay, ma'am, thank you. So we hope that your future studies will be available for us to read and also to learn more about gas hydrates. So next question, I think we're down to the three last questions. What were, I'm sorry, wait. So what were the main findings or result obtained from analyzing the 2D seismic reflection profiles from the RNV VEMA and RV Ocean Researcher 5 expeditions along with the Manila Trench for ARC region?
Well, all those data, even the old data, when we reprocessed and reinterpreted them, mostly those data were used to define and delineate the BSRs. Like I said, the BSR is what we need to determine the depth of the gas hydrate stability zone. So from all those lines that we looked at, some of them we were able to clearly see the BSRs. Some of them it was not as obvious. But when we combined all the information, then we were able to say na, okay, the presence of BSRs in several of the seismic sections tells us na we are not imagining the gas hydrates that we think are present in the Manila Trench region. I think with the substantial data that we looked at, there is really a potential for gas hydrates. So yun talaga yung key factor, key result ng work is for us to report for the first time that we see BSRs, and the BSRs we think might indicate gas hydrates. We may be wrong, but sana we're not wrong. But only drilling, subsequent drilling, and other further studies will confirm whether we are right or wrong.
Thank you, ma'am. So we have a question from our chat box from Mary Jane Diaz Santa. As a prominent figure in the field, what advice would you give to aspiring geologists or geoscientists who are just starting their career?
Ano bang yung career, yung starting ng career ninyo is as what ba? Are you starting your career in the academe, in the industry? Saan ano kayang aspiring as what? Kasi ang pinaka-advice ko to aspiring geoscientists is that you have to be very curious, 'di ba? Although curiosity kills the cat in terms of the cat, but in the case of scientists, curiosity should not be a hindering factor. Kasi if you are curious, like your questions, ang dami yung questions, that comes from a very curious mind. So that is very good because if you're curious, then it means you will also be interested to find the answers to those questions. So if you are interested to find the answers to those questions, the ibig sabihin, you might also be motivated to try to address those questions yourselves. So for aspiring geoscientists, wherever your career takes you, whether you go to the industry, to the academe, to government, you have to be very curious about a lot of things, and you have to be reading a lot to know what is going on. So especially for gas hydrates, if we want to do further studies on gas hydrates, then we need to keep reading what other countries are doing. How are they doing it? China is extracting gas hydrates daw with their successful test production. How did they do it? I'm sure they're not going to share the technology, but I mean, it tells you what is there out there, what others are doing, and therefore it also motivates you to try to see if those things that they're doing are things that we can also do here in the Philippines. Diba? So curiosity and being very well versed in terms of reading, especially science articles para makatulong to help you see what is available and what is out there in terms of scientific and research questions.
That's a very good advice, ma'am. So, another question. Were there any unexpected challenges or interesting observations during the data processing and analysis stages of the seismic reflection datasets?
Well, the challenges were not in the processing and interpretation. The challenges that time last year, in 2022 and in 2023, the challenges were in terms of the interference. Yung lahat ng nakikita nyo sa news ngayon when it comes to the West Philippine Sea, the interference by our neighbor, that is something that was experienced firsthand by our scientists. So when they were doing the marine survey within the Manila Trench, you can just imagine that it's just mga 50 to less than 100 kilometers from the western coastline of Luzon. They were shadowed by the research vessel, no, by the Coast Guard of the neighbor. So yung nakatutok sa kanila, and if it's a dangerous interference, especially when they deployed the streamer, kasi kung sinagasaan ng vessel ng neighbor yung streamer, then that's a very expensive equipment, and that will cause the whole team to discontinue the survey. So sayang, because deploying a research vessel is very expensive. Booking time to use the research vessel is very expensive. So kung magkakaroon ng disruption just because there's somebody who is not supposed to be interfering, then that is dangerous. Aside from being dangerous, it's also very expensive. So yun, first-hand na experience ng mga students namin at saka nung Taiwan counterparts namin. So it's challenging now to do marine scientific research in that part kasi magkakaroon kayo ng may naka-escort sa inyo na hindi naman dapat naka-escort sa inyo. And you have seen that also in the news with some other scientists that are not doing these types of surveys. So that was the most challenging part. There were no challenges. Well, a little bit of challenge in terms of seismic data processing kasi hindi ganun kabilis yung internet natin. And sometimes we need internet access to the facilities in Taiwan. So medyo na-hamper yung processing namin. But for the most part, it's really during the marine survey that the challenges were very, 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 very obvious.
So another question. So we just want to ask, have you considered pursuing an interdisciplinary investigation through integrated petrophysical and geomechanical modeling to reduce significant uncertainties prior to robustly characterizing this complex hydrate-bearing system?
Well, we don't have the opportunity yet to do interdisciplinary work with whoever might be interested, especially to look at the petrophysical characteristics. If there's anybody among you who would like to explore some potential topics with us, that's something that we can discuss. Although I'm not sure what the requirements are when it comes to the petrophysical characterization, the geomechanical aspect. Those things are not within our realm, kaya wala yan sa consciousness namin. But if somebody comes up to us and maybe potentially discusses the topic with us, and if it's something that we can work with, then we're open to that potential collaboration. Wala palang opportunity, so kaya hindi pa namin nagagawa before.
Thank you, ma'am. I think we are down to our last question. In the released article regarding the presence of gas hydrates in Manila Trench, it is mentioned that the area of gas hydrates is as large as the island of Palawan, and also stresses out to the threat of producing it unsafely to the environment. In your opinion, given the condition that we have here in the Philippines and the technology for producing gas hydrates here in Asia, is it possible to produce safely?
Yun nga, that's one of the challenge really, is that the technology is not yet very well developed in terms of the careful extraction of gas hydrates. Pero once the technology is there, then we really should consider using gas hydrates. Once the technology is developed and once we have the resources to also adapt and develop the technology, then that is something that we should consider kasi we are running out. The Malampaya gas field is running out and we have no other potential oil and gas field that will replace the Malampaya unless meron kayong alam na hindi ko alam. Diba? So we really have to look, we're now looking, the DOE is now looking instead at offshore wind. Again, how long does it take to do the exploration all the way to the development of an offshore wind farm? I don't know. I don't know the time frame. So ito, even if we decide to use gas hydrates, as I said, it might take us 10 to 20 to 30 years before we can do commercial extraction. Pero wala pa tayo doon kasi nga, the drilling part, we have not done. Further exploration work, we have not done. So it's in your lifetime that you will need to make the decision if you are going to use gas hydrates. Baka hindi ko naabutan yung pag-develop ninyo ng gas hydrate field in the Philippines. Diba? So, but it's something that should be considered. But yun nga, the technology has to be studied carefully. Baka nasa inyo ang makaka-develop ng technology to carefully extract the gas hydrates. Why not? Once it's there, we should seriously look at gas hydrates.
Maybe it will be in our generation.
Yes.
Okay, so thank you for answering all our curious questions, Dr. Dimalanta. And now I give the floor to our Masters of Ceremony.
Grabe partner, that's a lot to digest. Napakaganda po ng topic and unconventional siya in a way na parang gagana talaga yung curiosity mo na how will this thing work para makatulong din sa ating energy sector, syempre. Ano masabi mo doon, partner?
Speechless. Very interesting topic po. As in, so, very urgent na po yung paghahanap ng ating energy source in different parts of the world. So, very informative po siya. The whole discussion po. Thank you, ma'am. Thank you.
And now, we would like to extend our gratitude to Dr. Dimalanta by awarding their Certificate of Appreciation. So the Certificate of Appreciation is hereby awarded to Dr. Carla B. Dimalanta for their invaluable guidance, mentorship, and unwavering support provided during the Mentor Connect, Empowering the Petrophysicist and Well-Like Analyst of Tomorrow, hosted by Society of Petrophysicists and Well-Like Analysts, Batangas State University Student Chapter. Awarded with gratitude this 28th day of April 2024 at Batangas State University, the National Engineering University, Alangilan Campus. Signed by the event head Cristel Chelsea Cataga, Jules Andre Florendo, John Kevin Navarro, and signed by the president of the SPWLA, Bat State USC, Mary Jane De Asanta, and the SPWLA, Bat State U Advisor, Engineer John Kevin De Castro. So thank you so much, ma'am, for that very fruitful discussion. And for everyone po, let's open our camera to have a photo opportunity with Dr. Dimalanta. Yan guys, open cam tayo. May
Alright, okay na ba? Okay na ba, everyone? Alright, by page tayo. Ay, by page. By page. Ang ngiti dyan kasi hindi niya alam kung saan page, kung saan part kaya. 1, 2, 3. Alright? Isa pa, hindi matanggal ang ngiti. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Ayan, mukhang okay na ang lahat. Thank you po, ma'am. Thank you for that.
Thank you very much for joining me this afternoon. Thank you for the invitation.
Thank you so much, ma'am.
Thank you.
Once again, thank you, Dr. Carla. We are nearing the end of our program today, partner. Medyo nalulungkot ako. Parang kaya pa hanggang 7.
So tama ka dyan, malapit na tayong matapos. Pero, meron pa tayong isang hindi nagagawa. Ano ba yun, partner?
Parang nagawa na naman kanina, ulitin lang naman natin. Okay. So to begin with, gagawin ulit natin ang Bring Me. Yan.
Ang dami natin, hindi tayo match sa duck race.
So, siguro alam naman na natin yung mechanics ng Bring Me, no guys? First, magbibigay kami ng item. Tapos, kailangan nyo lang i-open yung cam nyo. Sabihin yung name nyo, organization nyo, level, and shout, Mentor Connect. Yan! By the way guys, may cash prize to. Sino ang mauunang gumawa ng lahat ng yan? So partner, ano ba ang mga items natin na dapat hanapin nila?
Ready na ba yan? Ready na ba yan?
Ready na ba ang lahat? If pwede sumali ang officer.
Mamaya.
Kaya pang ipadala namin.
So for our first item, bibilang pa ba tayo dyan? Parang ready na naman lahat eh.
Uy! Uy, drum roll!
Finally. Okay, for our first item. So, bring me baso na katulad nung sa Jollibee. No, just bring me a baso. Tapos, paunahan ulit tayo. Mag-on cam and then on. Okay, may nag-on cam na ba dyan? Kasi kung pwede naman, patiman ko na lang. Baso ko sa tabi. Ayan, meron na. Ayan. Okay, so please open your mic po. May isa lang naman siya. Gawin na pa, kuya. Di ko makita ang iyong name. Masyadong mahaba. Ayan. You can open your mic na po and then sa nabanggit ni Gabby kanina, state your name, program, organization, and then shout Mentor Connect. Si Kuya pong SPE, Batstate USC, Rodel Jr.
Hello po, Rodel Tiboydos Jr. po from Petri 3203, Society of Petroleum Engineering po.
Yan. Hisigaw pa yan ng Mentor.
Yun, Mentor Connect.
Yan. Medyo yung energy, lumilevel naman. Yan. Congratulations! Yes, buhat na naman tayo ng lakpak. And so, susunod na item naman.
So for our second item ay folder. Kahit anong klaseng folder na. Paano makita nyo sa desk nyo, sa table nyo, sa bag nyo. Yan. Kasi magtatay tayo school supplies. Actually, hindi ko kasi nakakita.
Alright, so pipiliin natin ating president. Sino pong nauna, president?
Florence on my end.
Oh!
So please open your mic.
So, my name is Lord Michael M. Dagdag from Society of Petroleum Engineer, Adamson. Yun lang. Mentor Connect.
Parang kaya pa lang sa mga taga-Adamson yung Mentor Connect.
Kaya pa yan. Para mga 5 tao, kaya. Wala sa library ata. And congratulations po.
Woo!
Ayan, dalawa na.
Partner.
Dalawa na. Nakakalimang ice cream. Pwede ng palimang ice cream. And so, para mo dagdagan.
Namit ako, girl. Ayan. Okay na ba? Ayan, so for our third item, dahil masyadong malusog na yung wallet ng ating so, naman pa natin ang third item. Bring me relo. Ayan, kahit may nakasukdik pa lang, nasa braso niyo pa yan, okay lang. Yan! Sino naman?
Parang nanalo na si Arnel kanina. Yaya ka sa amin
Sino muna?
Sino naman sa'yo?
Pwede maulit ang nanalo?
Pwede ba maulit ang nanalo, guys?
May nakontra. Bawal daw umulit.
Bawal ba ulit?
Oh, bawal daw. Sorry, guys.
More opportunity sa iba. Bilisan nyo.
Magkaibang student po.
Ibang student daw, ibang student. Pwede ba yan? Pwede ba yan? Ikaw po ang papipiliin natin.
Si Kuya Gab po ang pagpiliin natin dahil siya po ating pinaka-senior. Kuya Gab, sino po? Pwede po ba yun na kahit ibang student?
Pwede na, nakikisama lang naman sa ano eh. Camera pa sa nata.
Ay, banda daw.
Pwede na yan. Basta natin.
Ay, open mic na.
Sino ba yan?
Nasa Zoom ka naman. Nasa Zoom ka naman. Mentor connect.
Alay, hindi narinig ang name. Paulit.
Mentor connect.
Ala, kayang lakasan.
Kaya sa live.
Mentor connect.
Yeah! Napilitan. Ayan.
Game na game.
Ayan,
Okay.
congratulations.
So, guys, for our fourth item, hindi ko lang may hirapan yung iba dito, pero iba hindi. So, bring me mouse. Kahit buhay na daga, okay lang.
Pwede, natanggap kami ng gano'n. Pwede rin yung may wire. Pwede rin.
Pwede wireless.
Nasa bawat officer. Kahit ako. Kala nyo kahit ako.
Oh, talaga naman ang officer.
May napag-open mic. Open ka. Ayan!
Ayan.
Finally, nanalo ka rin after third try. So, open your mic, state your name, institution, your level, and shout Mentor Connect.
I am Woodrow Stephen B. Granada, SP Bat State USC, BSPT, Mentor Connect.
Magaling mo picture yan.
Bilis siya doon, bilis. Congratulations. And then for our fifth item, last na to guys kasi medyo gupit-gipit na. Bring me tinidor. Yan. Good item. Tama ka dyan. Meron mo dyan, mag-on cam. Meron mo dyan.
Tinidor guys, kuha na.
Kuha na ako dito.
Kalian.
Yung totoong tinidor sana, kung pwede lang. Parang, ayan. Meron ba dyan? Meron. Kahit may kanin-kanin pa, okay lang.
Pwede kaya
Accepted
yun?
ba ulit yan? Tatanungin natin ang president natin, ipasa-pasa natin ang... Pwede po ba yun? Yung
Dapat
picture
yung
lang?
tinidor.
Ayan!
Yun
Ayan!
dapat.
Ayan! May nag-on cam na! Ito, si Mia Cristinel. And po, so open your mic po. State your name, your level, institution, organization, and then shout na.
Mia Cristina Isinagan po from Petty 1202 and SPE. Mentor Connect.
Yeah! Baka kaya naman i-on ka. Baka naman mapagbigyan kahit kaunti lang. on cam, tapos shout ng Mentor Connect.
Mentor Connect.
Yeah! Yeah? Sorry, medyo ano yung tao dito eh. Congratulations po, congratulations. Lahat po yan, may tagpa 5K. Charot. Lugi pala, lugi. Congratulations again to our raffle winners. Please private message your details in SPWLA Batangas State University SC Facebook page so we can send you your prizes. Kanina may nag-send na. Sabi, sila ang nanalo ha. Bilis-bilisan nyo na din. Baka makalimutan.
Sabi ako pa yung nanalo sa electric fan.
Inaano kayo ni Gabi. Ako yun yung anip yun.
Hindi naman natanda kasi bebe. So now, let's welcome the one and only, the president of SPWLA, Bat State USC, Ms. Mary Jane Diasanta, to deliver the closing remarks for today's event.
Good afternoon again. So as we draw our Mentor Connect event to a close, I want to take a moment to reflect on the insightful discussions we've had and valuable contributions we witnessed today. So throughout these events, we have explored petrophysics, well-like analysis, geoscience, and from the thought-provoking presentation to the engaging panel discussions, it has been inspiring to see such and expertise come together in one virtual space. I want to extend my thanks to all of the speakers, starting from Mr. Mario and Dr. Carla, for sharing their knowledge, experiences, and perspectives. Your insights and are undoubtedly enrich our understanding and spark something in our curiosity. It started such meaningful conversations. I also want to thank each and every participants for your active engagement and thoughtful questions. Your presence has been instrumental in making this event a success. And of course, none of this would have been possible without the dedication and hard work of our organizing team, Jules, Kenneth, and Chelsea. Your meticulous planning and tireless efforts behind the scenes have ensured a seamless and enriching experience for all involved. Thank you for your commitment to the excellence. As we conclude, let's carry forward the momentum and knowledge harnessed today. Ideas continuing visions. Let's try to turn our shared vision into action. And finally, I encourage each and one of you to stay connected and continue to explore opportunities, learning, and growth. Together, we can make a real difference in our respective fields and beyond. Thank you once again for your participation and enthusiasm. Here's to the success of our endeavors both now and in the future.
So thank you very much, Ms. Diasanta, our organization president, and thank you to all the attendees for joining us today. We hope you gain valuable knowledge and inspiration from this event. Also, we would like to reiterate our gratitude to our partners for their support. So this event is made possible by Society of Petroleum Engineers Palawan State University Student Chapter, Society of Petroleum Engineers Adamson University Student Chapter. Mentor Connect is co-presented by Association of Geologists and Geological Engineers of Papua in cooperation with Silliman University Geological Society and Philippine Association of Geology Student, Society of Economic Geologists Student Chapter.
We would like to acknowledge the
Oh my God.
We would like, again, to acknowledge the presence of Faculty of Petroleum Engineering Program, Batangas State University, Engineer 7 Medrano, and the members of Society of Petroleum Engineers, Batangas State University Student Chapter, and Student Association of Geological Engineers, Batangas State University. Sir Selwyn, baka naman pwedeng maka-on mic dyan and on cam. Ayaw. Wag na daw. Okay na.
So this concludes our
Mentor Connect, empowering the petrophysics And we'll like analyst of tomorrow.
Wish you all the best in your future endeavors, everyone. Thank you for participating in this event. We love you all.
And please take a moment to complete our post-event attendance and evaluation form posted in our chat box. And your feedback is important to us. Thank you for your participation.
So, for those interested in learning more about SPWLA Bat State U Student Council, Student Chapter, or if you have any questions or inquiries, you may reach us to our Facebook page at SPWLA Batangas State University SC.
Don't hesitate and be part of this great growing community. Again, I am Donna Evaristo, SPWA Bat State USC Treasurer for External Affairs.
And I am Marcos Gutierrez, SPWLA Bat State USC Communications Chairperson.
And we are Masters of Ceremonies now signing off. Thank you and have a great day.
Thank you, everyone.
Awalo din misteryoso, di pa rin mabasa ang iyong tunay na motibo.
Parang may sasayaw ng salamin-salamin.
Pagkita, taliwas sa iyong salita, pero ayokong magduda pagka lang sa simula. Maghihintay na lang na ika'y dumaan, sana ay maibsan ang aking pangungulila. Trapped in this fairy tale, but I don't wanna wake up in this dream, baby. Ayokong umasa sa paniniwala. May pag-asa nga ba na baka ang puso ko'y mapabigyan? Mahiwagang salamin, kailan ba niya aaminin kanyang tunay na pagtingin? Mahiwagang salamin, ano bang dapat gawin? Bakit ang puso'y nabibitin? Salamin, salamin sa dingding, nasaan ang pag-ibig? Salamin, salamin sa dingding, pwede mo ba sabihin? Salamin, salamin sa dingding, nasaan ang pag-ibig? Salamin, salamin, kailan niyo ba ko papansinin? Ayokong maniwala, eh, na baka mabaliwala. Oh no, pero sa iyong suya, mga matay nang umusap, di ko kayang magpanggap. Ano ba talaga ito? Maghihintay na lang na ika'y dumaan, sana ay maibsan ang aking pangungulila. Trapped in this fairy tale, but I don't wanna wake up in this dream, baby. Ayokong umasa sa paniniwala. May pag-asa nga ba na baka ang puso ko'y mapabigyan? Mahiwagang salamin, kailan ba niya aaminin kanyang tunay na pagtingin? Mahiwagang salamin, ano bang dapat gawin? Bakit ang puso'y nabibitin? Salamin, salamin sa dingding, nasaan ang pag-ibig? Salamin, salamin sa dingding, pwede mo pang sabihin? Salamin, salamin sa dingding, nasaan ang pag-ibig? Salamin, salamin, kailan niya ba ko papansinin? Mirror, mirror on the wall, please tell my Prince Charming I'm waiting for a swap. Bakit ba sikot-sikot, para bang pinapaikot-ikot talaga? Mag-isa na ba talaga ang next move mo? Gusto ko lang naman malaman, ano ba ang katotohanan? Oh, better say it now, it's not too late. I'm ready to be called a princess, hey. Ayokong umasa sa paniniwala. May pag-asa nga ba na baka ang puso ko'y mapabigyan? Mahiwagang salamin, kailan ba niya aaminin kanyang tunay na pagtingin? Ano bang sasabihin? Ano bang dapat gawin? Bakit ang the silent. Guided by the grip of your hand, I can feel you holding my world. Ano ba itong nadarama? Oh shucks, ito ba'y pag-ibig na? Totoo ba ang pinadama? Cause boy, it feels so good. Bawat aroma sumasaya, magmula nang nakita ka. Nawawala ng pangangamba, pag ika'y kapiling na. Feels like someone I'm with you, parang islang pantropiko. Can't wait to go back with you, sa islang pantropiko. Sa islang pantropiko. Sa islang pantropiko. Sumapit na ang araw, nang ika'y muling nakausap. Hinahanap ka sa tabi, di na mawala sa isip. Nakita kang papalapit, puso ko'y bigla rin napakali. Ano nga bang sinapit, kakapit pa hanggang muli. Following your footprints in the sand, to walking with you on the silent. Guided by the grip of your hand, I can feel you holding my world. Ano ba itong nadarama? Oh shucks, ito ba'y pag-ibig na? Totoo ba ang pinadama? Cause boy, it feels so good. Bawat aroma sumasaya, magmula nang nakita ka. Nawawala ng pangangamba, pag ika'y kapiling na. Feels like summer when I'm with you, parang islang pantropiko. Can't wait to go back with you, sa islang pantropiko. Sa islang pantropiko. Sa islang pantropiko. Island sitting on the white sand, guess if I'm in love with you. Cause with you, boy, I'm going crazy. You could be my baby, I could be a lady. Oh, oh, oh. Di na mawala ng kilig, nabigay riyan. Kasi para bang di na mapigil. Kumakabog, huminto, gumugulo ang puso ko sa'yo. Following your footprints in the sand, walking with you on this island. Guided by the grip of your hand, I can feel you holding my world. Ano ba itong nadarama? Oh shucks, ito ba'y pag-ibig na? Totoo ba ang pinadama? Cause boy, it feels so good. Bawat aroma sumasaya, magmula nang nakita ka. Nawawala ng pangangamba, pag ika'y kapiling na. Feels like summer when I'm with you, parang islang pantropiko. Can't wait to go back with you, sa islang pantropiko. Pantropiko, pantropiko, sa islang pantropiko. Pantropiko, pantropiko, sa islang pantropiko. Oh, hello there, misteryoso. Di pa rin mabasa ang iyong tunay na motibo. Ibang pinapakita, taliwas sa iyong salita. Pero ayokong magduda, baka lang sa simula. Maghihintay na lang na ika'y dumaan. Sana ay naibsan ang aking pangungulila. Trapped in this fairy tale, but I don't wanna wake up in this dream, baby. Ay.
Basta sa paniniwala, may pag-asa na ba? Nakampa ang puso ko, magkapit ka. Mahiwagang salamin. Ay,
Oh, wait lang. Magbilis lang. Kasi, ay by the way, congrats pala sa event. Lalo kay Jules, super success. Baya no, yung sa ano lang pala sa election. Mali pala yung nabanggit ko last time. Sino si Jay? Alisin ko muna. Huwag mo accept, pinaalis ko na. Yan. Bali, ang sabi ko kasi is yung election is from 22 to 26. Mali pala. Yung 26. Tapos, ang botohan is 28 or 29. bali ang botohan from 8 a.m. to 8 p.m. Tapos, ang mga pagbobotohan positions lang is President, Director for External Affairs, then mga chairpersons, DRRM chairperson, communication chairperson, events chairperson, membership chairperson, tapos yung sa finance, and bali sa finance ay tatlo, dalawang treasurer, isang auditor, and sa yung isa'y administrate, basta admin, ayun yung dalawang secretary. O nga, yung sa secretary. So, ayun lang. So, nagkamali lang ako ng banggit. That would be all, guys.